Find a formula for the exponential function passing through the points -3 1/2 and 1/8. Okay, so where do we start? Well, first, we're looking for an exponential function. Now, we would solve this problem the same way, regardless of if it was a different type of function. But in this case, we have an exponential function. Either way, we're given a couple of points. And so we're going to plug those points into a function and solve for some unknowns. That is nothing specific here to exponential functions. But since we're looking for an exponential function, let's start with that one. So step one, definition. What is the definition of an exponential function? If you don't know that, you can't start the problem. Can't do the problem. So by definition, an exponential function is a function of the form b times a to the power of x. We call it an exponential function because our variable x occurs as an exponent. Okay, but we have a couple of unknown constants here. There's a b and an a. All right, so we have to figure out what is the value of a and b. Right, it's going to be f of x equals 5 times 3 to the x or -2 times 8 to the x. We need to figure out a and b. So the way we do that is we come over here. We're given some information. We need to use that information. Now, each one of these points is an x and a y, but we're not talking about equations. We're talking about functions. So we don't say x and y. We say x and f of x. All right, so we have two pairs, two input-output pairs. Right, these are points on the graph. So let's see. I'll start with the 1/8. That just looks like it's a little bit easier to work with. So first piece of information, one, let's label this point number 1. When the x value is 1, the f of x value, the function value, is 8. Right, so we could replace 8 for the f of x, b times a to the power of, and instead of x, we'll use the power of 1. Right, so 8 is equal to b times a to the first power. Now, anything to the first power is equal to itself. So we could say 8 is equal to b times a. All right. By itself, that doesn't help us finish the problem, but that's one step in the direction of our answer. So let's use that second piece of information. All right, so we're done with the 1/8, right? So that second point, when x is -3, the y value or the function value is 1/2. So we could replace the f of x with 1/2 is equal to b times a to the x, and instead of x, we'll use the power of -3. Okay, so now we have this system of equations. We've got 8 is equal to b over 8 is equal to b times a, and 1/2 is equal to b times a to the -3rd power. We could do a little bit of algebra here. We have a system of equations. So what we could do is we could substitute one into the other. Right? So we don't know what a is. We don't know what b is. But if we take this first equation that we found and divide both sides by a or b, either way, it doesn't matter. I'm going to divide by a. We could get the same answer dividing by either one. We just want to isolate one of those variables, either the a or the b. So if we divide both sides by a, we'll get 8 over a is equal to b. Okay, 8 over a is equal to b. And now we could use this because in the second equation, there's a b, right? And this 8 over a, this equation right here, this is saying the fraction 8 over a and the letter b are interchangeable. They're equal to each other. All right, so now let's take this second equation, and instead of using b, let's say 1/2 is equal to, well, what is b equal to? That is 8 over a. And then that's multiplied by a to the negative third power. Okay, so now this is what we want. We have an equation with only one variable, only one unknown, a. Now we could solve for a. We have to apply some rules of exponents here. So let's see. We could say 1 over 2, left side is 1/2 equals a to the negative third power. Well, a negative exponent means reciprocal. So that a to the third power comes to the bottom of the fraction. So that's going to be 8 over a to the fourth power, right? There was already an a on the bottom. And these three a's come to the bottom. That's what the negative exponent does. It's reciprocal. So we actually have, let me just write that intermediary step. We have a times a to the third power, right? That a to the negative third comes down. So that becomes 1 over 2 is equal to 8 over a to the fourth power. At this point, we have a fraction equaling a fraction. We could cross multiply. 1 times a to the fourth. That's a to the fourth is equal to 8 times 2. 8 times 2 is 16. So something to the fourth power equals 16. That's going to have to be 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 to the fourth power is 16. Or you could use the calculator, take the fourth root of 16. Either way, you're going to get a is equal to 2, right? And that's half our answer. Right? The original problem is up here. A equals question mark, B equals question mark. So we have two values to find. We just found one of them. All right, so now A, get rid of that question mark. A is equal to 2. Let's zoom out a little bit. We need a little bit of more room. So now, second part of the problem, find the other variable, B. Find the other unknown constant, B. So f of x is equal to b times a to the x, but we already know now that a is equal to 2. So it's b times 2 to the power of x. So now we need to solve for b. Now we can take one of those points and plug it in. Let's use the point 1, 8. When the x value is 1, the y value is 8. So we can say 8 is equal to b times 2 to the first power. Or 8 is equal to 2b. And if 8 is equal to 2b, if we divide both sides by 2, divide by 2, that will give us 4 is equal to b. And this right here, this is our exponential function. Plug in the 2 and the 4 into the definition, the general form of the exponential function, and we get f of x is equal to b times a to the x, or 4 times 2 to the x. And that does it for this one.